the equation x squared plus y squared minus 2x plus 6y plus 3 equals 0 is equivalent to what? So if you look at each of the answer choices, it's essential that we realize right away that these are formulas for circles. So immediately you're thinking, what's the formula for a circle? Right? This is a circle problem. If you don't know that right away, then you should become familiar with this formula. X minus a squared plus y minus b quantity squared equals c squared. This is the standard formula for a circle where c is the radius and AB is the center of the circle. So for instance, if you just have x squared plus y squared equals c squared, then that means a and b are 0 and it's centered about the origin. In this case, or in all of these cases for these different options, they're always minus or plus something, so they all have center points that are not at the origin, that are somewhere else. And for the most part they have different radiuses, right? This is different radius than these. And this one should be suspect right away, because if this is -3, then this is supposed to equal c squared. Now what's the square root of -3? We can't find that, right? It's an imaginary number. So right away we should be suspicious about the first answer choice. I'm not going to cross it out just yet, because maybe there's something hidden in there that we haven't found yet, but I'm already not very keen on choosing number 1, so we're going to focus on the other 3. Okay, so now the question is, how do we take what we were given and get it into this form, this equation of a circle? So let's work on that. Now I'm going to rewrite this given information down below, but I'm going to group the terms that have x in them together and the terms that have y in them together and the constant terms after that, and then we'll go from there. So in the first step we're going to write x squared minus 2x, and I'm going to leave some space, and you'll see why in a minute, plus y squared plus 6y, and I'm going to leave some more space, and I'm going to put the plus 3 out here, equals 0. Okay, now why did I leave those spaces? I want you to imagine that we have to get these into a binomial squared for both the x and the y. So can you imagine that we would group all this together and we're going to make these trinomials that are actually a perfect square? And I think you'll see what I mean when I fill these in. So what binomial multiplied by itself would, if you didn't have to worry at all about what that third term was going to be, what binomial would have a middle term of minus 2x? What if you were to have x minus 1 quantity squared? Wouldn't that work? Then you would have x squared minus x, which is minus 2x. And what would the last term be? Well, the last term would be plus 1. So that's what I'm going to fill in there, plus 1. But now realize that by doing that, I'm adding 1 to what's on the left side of this equation. And I can't do anything to the left side of the equation unless I also do it to the right. So if I'm going to add 1 over there, I better add 1 over here as well. So now we've taken this trinomial, turned it into a binomial, and that's okay, but in order to make that possible we had to add 1 to the left side. We've also added 1 to the right side. We're going to follow that same procedure for the y terms. We want to make y squared plus 6y plus or minus something, a third term yet to be determined, where we can express it as a binomial squared. So I'll put a binomial down here. What should this binomial be? Well, the middle term has to work out to be plus 6y. So what should go here? It should be plus 3y. I'm sorry, not 3y, just plus 3. Y plus 3. Why will that work? Well, let's see what happens if we were to FOIL y plus 3 squared. We get y squared plus 3y plus 3y would be plus 6y. And then the last term would be what? 3 times 3 is 9, so plus 9. So I'm going to add 9 to make this the right trinomial that it would need to be in order to make this possible. But in order to make it okay to add that 9 on the left side, we have to add 9 on the right side. This process is called completing the square. And now all we have to do is tally up these constant numbers on the outside. And for this part, we're going to get everything over onto the right side. So I'm going to subtract 3 over to the other side. And what we're left with is 0 plus 1 plus 9, and then we're going to subtract this 3. So that's 10 minus 3, which is 7. And really, we are done. We have the quantity x minus 1 squared plus the quantity x plus 3 squared equals 7. And that looks exactly like answer choice 2. Just for your information, if you were wondering what this actually looks like, the value of a would be negative 1, b would be negative 3. I'm sorry, this would be positive 1, not negative 1. Because a, if you look at the original formula, it comes in the form of x minus a. So if it's already a minus, whatever's there is positive. So it's a equals 1, b equals negative 3, because here it's a plus, so it switches. And the radius would be the square root of whatever constant term is on the right side. So if it's 7 out there, then c would equal the square root of 7. So if we wanted to draw this circle, we could do that. We just need a little. So the center point would be at 1, negative 3. So that's about right here. And it would have a radius of square root of 7, which is somewhere between 2 and 3, right? So it would look something like this. And that's it.